Hey GED students, it's GED question of the daytime, and we're doing 2 truths and a lie. Again, GED style, or maybe I should have said 3 truths and a lie. And we see that it says one of the statements below is a lie. Can you spot the fraud? Love to use these to talk about some really common errors that GED students make. This particular one, as you can see, involves a bunch of fractions. So let's take a look here. First statement, 1 minus 1/4 equals 3/4. Now, GED students spend a lot of time working out problems like this that I've found, doing all kinds of side work and scratch work, when I think this is a problem you should be able to do in your head by just drawing a picture. So maybe that's not in your head on paper, but at least we could do it with a simple diagram instead of all the crazy stuff that I see you guys writing. So let's take a look at what I mean. So the first thing I'm starting with is 1. So how about we just draw one thing? There you go. I drew one thing. Call it a pizza, call it a pie. Us math teachers tend to whenever we're talking about fraction, but there's my one circular thing. Now the next thing I'm supposed to do is take away a 1/4. What do I mean when I say a 1/4? I mean a 1/4 of that one whole thing. So I'm going to come right here and I'm going to cut this thing into 4ths so that I can remove a piece. I want you to imagine now, and apparently you can't do it with the technology that I have, that I am going to remove this piece. I can't erase it, so I'll black it out instead. Imagine this piece was removed. I perhaps ate it if it really was a pie or a pizza. It sounds like me. And I don't have that 1/4 anymore, but I do still have the rest of the pie. And if you recall, the pie's been cut into 4ths, so I still have 1, 2, 3/4. I don't have to do any complicated math to see that if I have one whole thing and if I take out 1/4 of it, I'll have 3/4 left. That was a true statement, not a lie. I'm looking for a lie, so I'll cross it off. Now, next one, students tell me all the time, must be a lie, and I say, really? Be careful. Next problem says 3/4 plus 7/8 is equal to 13/8. And students say, well, that doesn't make sense because 3 plus 7 isn't 13. And I would just have you recall that no matter what we're adding, whether it's fractions or decimals or units and word problems or even algebraic terms when we get to combining like terms, we've only ever been able to add and subtract the same kinds of things. So these two numbers currently, as it stands, 3/4 and 7/8, cannot add in their current form. Why? Because they're not the same kinds of things. The denominator of a fraction tells you what kind it is or what size it is. These are not the same kind or the same size, and so I can't currently add them. But what I can do is I could chop up all the fourths. Imagine that I had 3/4. 3/4, and I could chop them all up so that instead of being in size 4ths, they were in size 8ths. Let's give it a try. Now I've cut all my 4ths into 8ths, and how many 8ths do I have now? 1, 2, 3, 4, 5, 6. So I can say, oh, that 3/4, that's the same as if I had 6/8. It's the same amount as if I had 6/8. I just cut everything into 2 more pieces than it was cut before. And now I can add 8ths and 8ths very easily. 6/8 and 7/8 would give me 13 things of size 8th, 13/8. And now I can see that it doesn't matter that 3 plus 7 are not 10. You have to get the denominator the same before you can add fractions. So this was a correct answer. It is not the lie. Next one students really struggle with is fractions, multiplying with fractions. And I'm like, guys, multiplying with fractions is easier than it looks. Let's talk a little bit about what it means to take 1/3 of 15. So what I'd like to do is I'd like to start with the 15. I hope you agree with me that if I draw 15 little circles, that is a good representation of the number 15. Now, if I say 1/3 times 15, remember that multiplication, especially with fractions and percents and decimals, can be expressed as the word of. Multiplication is an act of scaling, it can make something bigger like we're used to, but it can also make something smaller. Taking a third of 15 is like breaking 15 into 3 equal pieces. So let's do it. 1 group, 2 groups, 3 groups. There, I took 15 and I broke it into thirds. Now, how many of those thirds do I get? I just get one of those thirds. So I just have one of those groups. 1/3 of 15 is 1, 2, 3, 4, 5 things. 1/3 of 15 is 5. Again, I didn't do it mathematically. I didn't put 15 over 1. I didn't cross reduce. I didn't multiply. I didn't follow any of the rules your teacher taught me. I just used some reasoning skills to see, of course, 1/3 of 15 has to be 5. I need you guys, just because you have fraction rules memorized, not to forget your common sense. Really, fractions should make sense. Now let's go ahead and look at 2/3 and 1/5. This is the one most students are sure is right. Obviously, since my other 3 were right, this must be the lie, but let's see why it's a lie. Look at what this student did. They said, oh, look, I'll just add across the top, and I'll just add across the bottom. And they forgot that rule that you can only add and subtract the same kinds of things. You cannot add 2/3 with 1/5 and expect it to suddenly create eighths. I'm sorry, that's not how math works. What you're going to have to do is you're going to have to cut these legit into some number of pieces so that we're talking about the same size piece. You know, we can't add thirds and fifths. What we're going to have to do is chop up our pies again until we have the same size piece. We have the same denominator. So the quickest way to do that is to multiply the 3 by 5 and the 5 by 3. We'll give them what they don't have. So I'm going to take 2/3. I'm going to chop it into 5 pieces. Now realize if I chop it into 5 pieces, it's going to chop the entire 5 into 5 pieces. So I'll multiply it by 5 on the bottom. And the pieces that I have will also be cut into 5. So I'll multiply it by 5 on the top. I'll end up with 10/15. Cutting each one of those 2 into 5 pieces each will give me 10/15. And then with those fifths, if I take the fifths and cut them into 3 pieces, then I will get 15ths as well. So I'm going to take that 1/5 that I have. I'm going to multiply it by 3 on the top and the bottom so that I do end up with 3/15. And now they can add 10 plus 3 is 13. 13 what? 13/15. Not even close to 3/8. That D was the lie. Great. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.